Preparing for interviews? Let's make it simple. Here are the most asked questions, explained with clarity and real-life logic. What is an operating system? An operating system is a system software that acts as a bridge between hardware and user applications. It manages hardware components like CPU, memory, I/O devices, and enables multitasking and resource sharing. It also provides security, file management, and process scheduling. Example: when you run Google Chrome, the OS allocates memory and CPU time to it and handles all I/O, like keyboard and mouse input. What is a process? A process is an instance of a program in execution. It has its own memory, program counter, stack, and data section. It can create child processes and move through different states like ready, running, and waiting. Example: opening MS Word launches a process that allows editing, spell checking, and saving files independently. What is a thread? A thread is the smallest unit of execution within a process. Threads share memory with other threads in the same process, but have their own stack and program counter. They are used for parallelism and responsiveness. Example: in a web browser, one thread handles page rendering, another handles downloading, and another monitors input, all within the same process. Difference between process and thread: a process is independent and has its own memory. Threads share memory space. Creating and managing threads is faster and requires fewer resources compared to processes. Threads are best suited for tasks that require shared data access. Example: a music player, process, plays a song using one thread and updates the UI with another. What is context switching? Context switching is the act of saving the state of a currently running process or thread and loading the state of another. It enables multitasking but comes with overhead due to state saving and restoring. Example: like a teacher pausing one student's question to help another, then resuming the first. What is CPU scheduling? CPU scheduling is the mechanism the OS uses to determine which process gets the CPU next from the ready queue. It aims to optimize performance metrics like throughput, turnaround time, and CPU utilization. Example: a scheduler like round robin gives each process a small time slot in a cyclic manner. What is FCFS scheduling? First come first serve, FCFS, is the simplest CPU scheduling algorithm. Processes are executed in the order they arrive. It is non-preemptive, which can lead to high waiting time for short jobs. Example: waiting in line at a bank, whoever comes first is served first. What is round-robin scheduling? Round-robin assigns a fixed time slice, quantum, to each process in the queue. After each time slice, the process is moved to the end of the queue if not completed. It is preemptive and ensures fairness. Example: each student in a discussion gets 1 minute to speak before the turn rotates. What is SJF, shortest job first, scheduling? Shortest job first executes the process with the least burst time next. It minimizes average waiting time, but may cause starvation for long jobs. It can be preemptive or non-preemptive. Example: a person with just 1 minute work is allowed before one with a 1-hour task. What is priority scheduling? Processes are scheduled based on priority. The process with the highest priority runs first. Lower priority processes may suffer from starvation unless aging is used. Example: in a hospital, emergency cases are prioritized over routine checkups. What is a deadlock? Deadlock occurs when a group of processes are each waiting for resources held by others, and none can proceed. It arises if 4 conditions: mutual exclusion, hold and wait, no preemption, circular wait, hold simultaneously. Example: 2 friends each holding one chopstick and waiting for the other to release theirs to eat. What are deadlock conditions? The 4 conditions are: mutual exclusion, one resource used by one process at a time; hold and wait, processes hold one resource and wait for another; no preemption, resource cannot be forcibly taken; circular wait, circular chain of waiting processes. All must be present for a deadlock to occur. What is virtual memory? Virtual memory allows the execution of processes not completely in RAM by using disk space as an extension. It's managed using paging or segmentation. This enables large apps to run on limited RAM. Example: swapping parts of Photoshop to disk when editing a large image on a low RAM PC. What is paging? Paging divides memory and logical address space into fixed size blocks. It avoids external fragmentation and allows non-contiguous memory allocation. Address translation is done using a page table. Example: a book with equal sized chapters, even if some are mostly blank. What is segmentation? Segmentation divides memory into logical units like code, data, and stack. Each segment can grow independently. It's more user-viewed compared to paging. Example: your office filing system. One drawer for bills, one for resumes, one for memos. What is thrashing? Thrashing happens when the system spends more time swapping pages than executing processes. It severely reduces performance and is caused by overloading the system with too many processes. Example: constantly taking out and putting in books while studying without actually reading any. What is a system call? A system call is a mechanism that allows a user program to request services from the OS. Common system calls include file read or write, memory allocation, and process creation. Example: calling OpenINC to read a file internally triggers a system call to the kernel. What is the kernel? The kernel is the central part of the OS, responsible for managing system resources and communication between hardware and software. It handles memory, I/O, CPU scheduling, and device control. Example: it's the OS's brain. Every action like saving a file or opening a program is routed through the kernel. What is a semaphore? A semaphore is a variable or abstract data type used to control access to a common resource in concurrent systems. It avoids race conditions using wait and signal operations. Example: green or red signal, letting one car go at a time through a narrow bridge. Difference between semaphore and mutex: a mutex is binary. It unlocks one thread at a time. A semaphore can allow multiple processes through a counter mechanism. Example: mutex equals one bathroom key, only one user. Semaphore equals 5 seats in a cafe, 5 people allowed at a time. What is a zombie process? A zombie process is one that has completed execution but still has an entry in the process table. It occurs when the parent process has not yet read the child's exit status. Example: like a ghost lingering because its work is done, but no one acknowledged it. What is a daemon process? Daemon processes run in the background and perform specific functions without user interaction. They start at boot and usually don't have a terminal. Example: in Linux, cron daemon handles scheduled jobs like backups or updates. What is demand paging? Demand paging loads a page into memory only when it is needed, reducing memory usage. If the page is not in memory, a page fault occurs, and it is loaded from disk. Example: open pages of a book only when you want to read them, instead of reading everything at once. What is Bilardi's anomaly? Bilardi's anomaly is the unexpected increase in page faults when more frames are added using FIFO page replacement. It shows that more resources don't always mean better performance. Example: getting more lockers but still misplacing items more often. What is swapping? Swapping is moving a process from RAM to disk, and vice versa, to free up memory. It's used in memory management to ensure active processes can get RAM access. Example: moving rarely used clothes from your wardrobe to a suitcase to make space for daily wear. If this made OS easier, hit like, subscribe, and ring the bell. Share it with your study buddy and comment what you want next. See you in the next one. Keep learning, keep growing.